As developers and teams, what are we trying to do? Firstly, we're trying to write correct code. Why? We want code that does what we want it to do. That's what people are paying us for. Part of this comes down to testing, so unit testing, acceptance testing, and integration testing. The other part of this is writing defensive quality code that avoids the pitfalls that cause common bugs. We want to write clean code. Once our code is written, someone has to maintain it. This could mean someone needs to explain the logic to the next developer or to the business months or years later, so we need to be able to understand what was done if the original developer or developers are not available or don't remember. We want to write maintainable code. Again, someone will need to change the code, either because it is doing a great job and they want more features, or because it doesn't work and needs to be changed. For management types, we need to write cheap code or value for money code. Trying to write correct, clean and maintainable code. All this is really helping us to do is write the cheapest code we can. Software is an investment and we want to get the most value from the money we spend. So I don't mean using the cheapest developers you can find or sending all the work offshore and expecting some value proposition. I mean writing code that has the lowest cost of ownership for the business. So this means that it's easy to change, it does what it's supposed to do, and it also doesn't break and corrupt data in production. It performs well and doesn't require a lot of operational support. So how can we measure and achieve clean and maintainable code? So just run through some terms just to help the rest of the presentation more understandable. So the first term, what is continuous code inspection? So from SonarQube, continuous inspection is a holistic, fully realized process designed to make internal code quality an integral part of the software development lifecycle. By raising its visibility for all stakeholders throughout the lifecycle, continuous inspection enables enterprises to embrace code quality wholeheartedly. So it is putting code quality in front of developers, managers, and other stakeholders. Continuous code inspection also helps us track and measure our technical debt. So, by always addressing code quality and standards as we develop, we get better value in the long run by doing it as we go, rather than trying to do it at the end of the project, or in the worst case, not at all. So what is technical debt? Technical debt is a measure of how costly non-ideal code is over the longer term. It is trying to measure the additional cost of writing code now, taking into account bad code that has come before us. The more code that we have that is hard to understand and change, the harder it is to write new code, so hence the technical debt is high. The higher the technical debt, the more costly and risky software development is. What is FindBugs? FindBugs is a static code analysis tool for finding common coding issues. If you want a tool that finds potential programming bugs for you, then you can use FindBugs. Examples of bugs that it finds include unsafe casts, possibly ignored exceptions. Something or an object is always null. But the downside of FindBugs is that it is only for Java. What is PMD? PMD is a static code analysis tool for checking bad coding practices. Examples of bad coding practices include empty try-catch blocks, overcomplicated expressions, unused variables, unnecessary loops and if statements. It also includes CPD, or copy-paste detection. But again, the downside of PMD is that it is only for Java. What is CPD? CPD, or copy-paste detection, is a practice of making sure we only write the code once. The more places that we have code, the the more paths of testing we need to have, and the more places we need to change as part of maintenance. What is CheckStyle? CheckStyle is a static code analysis tool that helps us to enforce coding conventions and standards. Examples include missing or improper documentation, line length of the code so we can read it on the screen, and naming conventions. But again, it is only for Java. What is cyclometric complexity? Cyclometric complexity is a measure of the number of linear paths through the code, which is a measure of code complexity. The more paths, the more complex the code. The more paths also means the more complicated and difficult it is to test. What is continuous delivery? This is a quote from Martin Fowler. Continuous delivery is about keeping your application in a state where it is always able to deploy into production. Continuous deployment is actually deploying every change into production every day or even more frequently. So what this means is that to produce value for the business, we need to deliver into production as often as possible. Continuous inspection has a role in the continuous delivery model. You can't have code ready for deployment to production if you don't keep the quality maintained all the time. So these tools, PMD, Find Bugs, and CheckStyle, tell us something about the quality of our code. They tell us how good our code is, help us find bugs, and help us measure technical debt or what we would like to fix to make development easier and our developers more productive. Which leads us into discussion on the SonarQube platform. What is SonarQube? SonarQube is an open source platform for continuous inspection of code quality. Open source tools for collection, measuring, and reporting of code quality and technical debt. It collects and tracks metrics over time. Other features include tracking who changes what. It also helps us track our bugs and potential bugs and reports them into one common area for teams to look at. It does it all the time, not just during an audit. What is Jenkins? Jenkins is a build server. It allows running SonarQube analysis and inspection as part of a release, part of a check-in, or in an ad hoc manner whenever someone wants. It integrates with SonarQube and the Build Breaker plugin so that SonarQube can be included in a continuous delivery process to stop or break the build when code quality falls. So what does the MB Precise plugin do? In simplest terms, it's like PMD, Find Bugs, and CheckStyle, but for message broker. So for ESQL, XSL, and message flows. So it performs the same kinds of checks as those products, but does it for our message broker code. Currently, it has 163 checks against the message broker code. Which you can see here in the quality profile. It has 10 additional metrics on top of the standard Sonar metrics of files, lines of code, and percentages of code duplication. It checks code for code duplication. And it also generates architectural diagrams and summaries, including a summary of all SQL used. So MB Precise statically analyzes flows, subflows, and ESQL. So it looks at what your flows are doing, how long they are, what paths are there through the code, are the connections making sense, and do the settings make sense. The violations that it covers includes filter nodes trying to change the message, filter nodes which have inconsistent connections with the ESQL. So for example, if a filter node returns true, and a filter node returns false, but there's only one true connection. Checks that compute nodes connections are consistent with the ESQL. So for example, if the compute node propagates to an output 2, but there's no output 2 connected. Checks the ESQL files for unused variables and methods. Checks the subflows for unused or unreferenced subflows. Checks to make sure that nodes have all the connections attached. Checks to make sure that the code is not referencing fields in the MQ header that don't exist. Checks ESQL for loops without a leave or what we call a potential infinite loop. Checks to make sure that ESQL atomics aren't calling other atomics, which could cause a potential deadlock. Checks for empty main methods, so in the case where someone's added some code but forgotten to add the code. Checks the build scripts against the message flows to make sure that the message flows are part of the deployment process. Checks for empty exception handlers to make sure that errors aren't being swallowed and messages being lost. And checks where deprecated nodes and parsers are used. So where MB precise configuration has been set up to allow reading the DB schema, which basically means giving the JDBC connection details to the plugin when it runs, so it can read the database and check the tables and columns. The plugin is able to provide checking and violations of the database usage by the code. So if we look here, we can look at the sort of violations that are produced when we're able to check the database. These database violations include wide selects, or where the code has a select star, which could be more resource intensive than needs to be. Checking table and column usage. So for example, checking to make sure that all the tables being used are actually defined in the database schema. Checking column usage to make sure that all columns being used are defined in the database schema. And also checking index usage to make sure that updates and selects use as many indexes as possible, or warn when as many indexes as possible, or at least one index aren't being used. MB Precise also looks at your MQ queue configuration files and how they relate to your message flows. So it checks your queue configuration files for queue, topic, and alias naming conventions. It checks to make sure that, or checks to tell you what queues have been defined but never used, so potentially queues that are dead. It also checks queues used that are not defined. This check is to make sure all the queues that have been created by the configuration files are done by the configuration files, not manually, so that the code does not break as soon as it gets into a test or worst case a production environment because the queue does not exist. MB Precise also statically analyzes the XSL files that it finds. The violations, or some of the violations that it checks in XSL files, are checking for inefficient root path access using XPath, and also checking for undeclared XSL variables being used, or XSL variables that have been declared that are unused, essentially dead code. MB Precise also publishes SonarQube metrics. So on top of the standard SonarQube metrics of files, lines, and code duplications, we also produce 10 additional broker-specific metrics. These include the number of nodes, which allows insight into which flows are more or most complicated and potentially the most resource expensive, the number of MQ input, HTTP input, and SOAP input nodes, the RCD nodes used in the system, as RCD nodes can be particularly costly in terms of resource usage, the length of the message broker flows, which allows insight into which flows have the longest possible paths and potentially are the most resource expensive, cyclometric complexity of the ESQL, which gives an indication of how difficult the ESQL is to test and how complicated it is, a measure of the string manipulation load, i.e. how much usage of string functions are there in ESQL, as string string functions can be particularly resource expensive. And the last metric, a weighted string manipulation load, which is similar to the string manipulation load above, but takes into account how many times a string function is possibly going to be called, where the string function is within a loop or an if condition. At the end of the analysis, the MBPrecise plugin generates a summary page of the broker project in HTML format. This is configured via the properties file by the MB flow diagram output path. So opening up our browser, and in this case we're using Mongoose web server. If we open up our browser and go to our generated folder and look in our output folder and look for our generated file, we can see the generated diagrammatic representation of our message broker flows. Now we can zoom in and zoom out just to see it in a bit more detail, but essentially this is giving us a representation or indication of which flows interact with other flows based on the incoming and outgoing MQ messages. So in the case here, we can see this particular message flow, by clicking on it, integrates via 5 queues with other flows. We can see here that flow display calls and drawing 6 message flow both write to Q1, which is consumed by our drawing 1 message flow. We can see here that the drawing 1 message flow produces messages that go out to drawing 3 message flow by Q3, drawing 4 message flow by Q4, and and the log message flow by drawing log. So this is a diagrammatic representation, gives an understanding or a better architectural understanding of what our message flows do. We can also see here in the diagram we've got 2 message flows sending messages to 1 queue. We can see the fan in and fan out effects. So by having these diagrams automatically generated by the plugin rather than manually generated by developers or architects, that gives us a couple of advantages. One being that they're always up to date. So when the code changes, the diagram changes, so we can understand the impact of changes to the architecture. It can be published in many forms, and it can be read via, for example, WebDev off a network drive, so it's a lot more publicly available, which means that can be used for all sorts of reasons. So it can be used for new developers coming into a team to understand the existing application architecture. It can be used by architects to understand the architecture as it develops to make sure it's consistent with what was initially designed or initially intended. It can be used by production support to understand where message flows or the business processes and how they map to message flows. So when they find out that a particular queue is broken or a particular flow is broken, it gives them indication of where in the business flow it actually occurs. And also it helps BAs to talk to business to explain the logic of the flows versus the overall code. So it gives them something diagrammatic to help everyone understand what's happening. So the second half of the diagrams generated is the summary tabs or summary table. So the summary lists various things. So it lists all the flows and allows you to navigate to them. It gives you a summary of all the queues and where they're used, in which particular flow, and allows you to navigate to them. It extracts all the SQL it can find from the message flows and from the SQL files, which allows, once this information is published, allows DBAs and developers to talk about the code from the perspective of what the application is doing to the database. So it gives you the file, the location where the SQL is found, the original SQL, and then what the SQL that actually be running was or will be. Gives a summary of all common ESQL files, which is navigatable. So this is useful for new developers or for architects to understand what common functionality is already available, which means, well, hopefully means less new code will be written that does exactly what old common functions does, and is also navigatable. Gives a summary of all the Java methods being used and where they're being used from. A summary of all stored procedure calls, what they are, or what they're called, and where they're used from. Gives a summary of all files being read by message broker and all files being written by message broker. It also gives a summary of all incoming URLs and the type, so whether it's a SOAP URL or a HTTP input connection, and the resource or the URL location that we're responding to. Gives a summary of all outgoing requests, so all outgoing services that are being used by flows. It also gives a summary of all thrown exceptions and a description of all exceptions to make sure the exception processing is consistent. So the DataPower product is an extension of the Message Broker plugin. The DataPower product provides additional rules for DataPower style sheets, i.e. XSL files. These DataPower rules include all the XSL checks the Message Broker product contains, plus additional checking for DataPower extensions. It checks DataPower usage of SQL, checks DataPower logging, DataPower variables and usage, and DataPower XSL messages. So for example here, we can see a DataPower rule violation against a DataPower style sheet, where in this case we're using a DataPower extension, or trying to use a DataPower extension that doesn't exist. So the DataPower extension for the MB Precise Sonar plugin means that you get some additional information in the generated diagrams. The additional information relates specifically to the DataPower components. So as far as the SQL statements generated, we will also get the SQL statements generated by the DataPower extensions in the DataPower style sheets. So for example here, we can see that we're using a DataPower SQL execute. This also includes within the queue summary. The queue summary also indicates where the queues are being used by DataPower, by the DataPower column here. Additionally, there is also a summary of all incoming and outgoing DataPower URLs. So for example here we can see that DataPower itself is calling out to, is using a SOAP call to a particular URL or resource. What does the SPrecise plugin do? It's like PMD, find bugs and check style, but for SAS code. SPrecise covers all your .sas files, i.e. your SAS code. It statically analyzes your code and tells you about common programming issues it finds, like we have lines that are too long, using data where it has not been defined, unused variables, undefined macros, dead code following a quit, and it also checks for infinite loops. It also collects 3 additional SAS metrics on top of the currently existing SonarQube metrics of lines, files. The 3 SAS specific metrics are the SAS complexity, the number of SAS procs, and the number of data steps. So what does the SPrecise plugin do? It's like PMD, find bugs and check style, but for Stelring Integrator business flows. Currently it has 51 checks against Stelring code. It has 3 additional metrics on top of the standard Sonar file metrics. It generates architectural summaries, including a summary of all SQL used. SI Precise covers all your BPML files, i.e. all your business flows. So it looks at what your business flows are doing, how long they are, and what paths there are through the code, and what settings there are. The violations that it covers include lock settings are consistent and matching. It enforces company headers on source files. It checks conditions and tries to make sense of the case and select matches. It provides dead code checking after exceptions. Checks all processes and makes us not invoking themselves, i.e. you won't get any circular references and infinite loops. It validates that the invokes from a BPML to another BPML makes sense, i.e. can actually find the destination that's being invoked. So when it statically analyzes your BPML files, it finds references to where SQL is being called, so that it can do database access checking. So the checks and violations it has for databases are: it checks that the tables being referenced are in the correct schema, or can be found in the schema. It checks for wide selects, i.e. where you're selecting more columns than you possibly need, so avoiding the use of select star. It checks that the columns being referenced exist in the tables that are being referenced, and it checks that inserts and updates and deletes are using indexes where possible, and warning when indexes aren't being used. It also interrogates your MQ configuration files, checking your queue, topic, and alias naming conventions. It checks to make sure that the queues being used by Stelring are defined in your queue configuration file. There are three extra specific metrics to Stelring which are provided. These are the number of operations, the SI complexity, and the number of code passed through the code. At the end of the analysis, the SI Precise plugin generates a summary page of all the information it finds about the project. This summary page, or the directory the summary page is produced in, is configured using the sonar.si.diagram.output setting in your Sonar properties file. So once the analysis is run, we end up with a architectural summary, or a summary of the different components of your Stelring project. The summary lists all the processes, with the process and file the process is in. A list of locks, lots of a lock name and the processes. A queue summary of all the queues used within the process. An SQL summary, so a summary of all the SQL that the Stelring code will run against the database. So this is useful for discussions between developers and database managers, or DBAs, on what the Stelring flows will be doing to their database, to try and help them understand the impacts and possibly provide advice as far as tuning and resource management. So what is Jenkins and what do we use it for? Jenkins is a build server, and in this video we'll quickly demonstrate how we can integrate Jenkins and Sonar to check our quality using something called the build broker. What we've set up here is a Jenkins job that runs our Sonar analysis. So inside our Jenkins job, we've configured some basic settings. For example, the subversion repository we're going to get the code from, the Sonar runner we're going to use, and the build triggering. So at the moment we're just going to build it manually, but we could have a build whenever someone checks in, or just on at a periodic basis. We can also, as part of a build step, we can add email notification for when builds fail, so that people will understand when the code quality has actually fallen. So now we've configured our Jenkins job, what we're going to do is we're going to run our Jenkins job and check the results in Sonar. So to run our job, we just select the run icon, which will schedule the build. From there, we can jump into the build details. And we can follow the build output. So we can see here that it's checking the SVN repository to see if there's any updated code, and there isn't, so it's using the code from the Jenkins workspace and running our analysis and publishing it into Sonar. We can follow the Sonar link provided to get into our Sonar workspace to see what's been done. So here we see the analysis, our issues, and our metrics. So the next step is to configure what's called the build breaker plugin in Sonar. So we're going into the settings. We're going to look at we're going to what's called the update center. We're going to look for the available plugins, and we're going to look for build breaker. In this case, I've already installed build breaker, which we can see here, and it's ready to go. What that means is that we can configure what we call a quality gate. So again, in the administrator and settings, we go into quality gates, and what we can do is we can pick a minimum level of quality that we will allow before the build breaker will break our build code. So in this case, we're going to set a very, very low threshold for errors. So we're going to tell it as soon as we get one blocker or one critical issue, we want our build to break. So looking at the results of our last Sonar analysis, we can see that we've got 0 blockers and 132 critical issues. So now with our build breaker configured at one blocker or one critical issue, the next analysis will actually fail. So when we go back into Jenkins and trigger our build, this time when we follow it, and watch the output, we can see that our build is actually broken, and it's telling us why our build's broken, because we open issues more than one. So when we go back into Sonar and refresh our dashboard, we can see that our Sonar project has failed a quality gate, and it's telling us the quality gate has been failed. So what we've now done with Jenkins, Sonar and build breaker is we built a quality system that stops code from being built when a certain level of the quality has fallen. We've set a very, very low level of quality for this case, so it's just purely for example purposes, but it just shows you what you can do with these tools. So we're just going to discuss some possible use cases for this breaking of the build technology. So the first one we cover is new projects. So in some ways it's the simplest one. You have a new project and you want to write the best code you have from the start. So you check the quality of them. You break the build at a low level of technical debt, or a low threshold for errors. This prevents bugs from happening as early as possible and from never creeping into your application code. The second use case is when you accept code from third parties, either internally or externally. So what you can do is you can set a threshold for bugs to be low. So you set a high quality standard for your code from the start. That way you can use the checks and the tool as an acceptance criteria for whether or not the company or the people giving you the code have provided at a high enough level of quality. You can also use the tools to help check that they're following the programming practices and patterns that you prefer, or in the reverse, check that they're not using patterns or programming patterns that you do not accept. The next use case is when you have an existing code you're enhancing. So what you can do for this is you can set the acceptable level of bugs to be above what you start with. So you're drawing a line on the sand, so that your current code, because it's existing, is at the minimum standard. As you enhance the code and you start doing your testing and developing, this gives you the opportunity to improve the code quality as you go. So as people check code in, by having the bar at or just above where their code originally started from, you shouldn't be introducing any more new bugs. As you progress, what you can do is you can over time lower that bar or increase that quality, so that as you incrementally deliver more function as part of your enhancement, you're also improving the quality of the code that exists as you go. So what that means for you is that you end up delivering a product with slightly higher or much higher quality than what you started with, and as a bonus for teams that will be following on from you, anyone who's picking up your code to be using it for the next enhancement or the next project will be starting with a higher quality base, so their level of technical debt that they're dealing with will be a lot lower. Maintaining code. So this is where you're looking at code that you're maintaining without any increase or massive increase in functionality. So what you want to do is set the bar as it is, and then, because you're assuming that the application is currently tested and currently works, any additional issues or violations you want the code to break or the build to break. That way you're maintaining at least at a minimum the level of code that it is currently there, without burdening people doing maintenance with having to try to improve the quality of the code. So the future releases of the products, we're going to be focusing on two particular areas. One is the diagramming, and the other one is mapping nodes. So the future releases, or the future functionality for diagramming, should include information about the alias and publishing and publish subscribes for the diagrams. So what this means is when we have MQs that are written to, the queue name that be written to could be an alias, and the actual destination queue could be a completely different message flow. So this just gives an extra level of information about how the system works. So when an alias or a publish subscribe is used, it builds that information into the diagram, so you can still follow it without having to go through the queue configuration to try and work out what the alias is to and where the publish subscribes are going to. The other information in the diagram we're looking to include is the inputs and outputs for HTTP and SOAP nodes. That way, when a broker calls out to another component outside the broker environment, we want to identify that particular SOAP call or web call is being made outside. And when the broker is actually calling to another component within broker that's actually providing that service, we want to build into that diagram some linking information to show that's where the actual flow of information is going from. The third part of diagramming we're interested in improving is looking to bring some deployment information or runtime information into the diagrams of what's actually being deployed into the environment. So what we're looking to do is bring in the information about the execution groups that the flows are being deployed into, so we can see which execution groups particular flows are in and which execution groups the flows that they're in will be interacting with. The other enhancement we're looking at for next or the future releases is to include mapping nodes, or rules for mapping nodes. At the moment we don't cover mapping nodes in very much detail. So what we're wanting to do is we want to build some rules out for what's good practice and bad practice in mapping nodes, and we also want to include our checks that we currently have for mapping nodes. So where mapping nodes are making use of the database, we'd like to be able to publish the SQL that is included in the mapping node, and also check the tables and columns that the mapping nodes are actually using. This will also give us the ability to check that the paths within the messages the mapping nodes are using correspond to the paths and the messages that the rest of the code, like the SQL code, is using, just to make sure there isn't a mismatch between what a mapping node is reading or writing to and what the incoming message or outcoming message has. So for more information, please email me at richard@bettercodingtools.com. Otherwise, there's more information available from our website, which is www.bettercodingtools.com, where you can also contact us using the contact page. Thank you.